A quick review of what we have done so far, so everyone is on the same page. So here's the document that I have been putting together along with this training so that we will have some point of reference. This will definitely not contain everything that I'm covering, but this contains a reference in terms of what all topics are being covered in the training. Wherein I started with that what kind of certifications do we have in Google Cloud, which basically starts with fundamental certification. Then you have administration certification. You have architect level certification. Fundamental typically covers introduction to Google Cloud, global infrastructure of Google Cloud, and all the services that exist in Google Cloud. So it basically talks about the theoretical aspects of those services and the use cases in which we can use a service. So fundamental typically covers that what are my storage services in Google Cloud. For example, we have object storage, which is Google Cloud Storage. We have relational databases in Google Cloud, which is which is Cloud SQL, which is Firestore. We have non-relational databases in Google Cloud, which is Bigtable. We have data warehouse in Google Cloud, which is BigQuery. We also have other services in Google Cloud. Cloud Spanner is another type of database that you have in Google Cloud. So it basically talks about it. Similarly, under compute, it talks about what are various compute services that we have in Google Cloud, which is Google Compute Engine, Google, you know, uh, Google App Engine, Google Kubernetes Engine, Google, Cloud Run. That's what it basically talks about. So basically, what are my different service categories and what are services that exist in those categories, as well as in what scenarios I should be using those services. That's what fundamental is all about, which is similar to AZ900 Azure Fundamentals and AWS Cloud Practitioner Certification. Then you have administration certification, which primarily focuses on provisioning, configuration management, or configuration lifecycle of core services of Google Cloud. So that certification is Associate Cloud Engineer. Here you learn how to provision a service, let's say cloud storage bucket, and then you look at various configurations which are available, which includes administration as well as configuration management. So you manage the life cycle of that service, which starts with provisioning of the service and then using that service throughout its life cycle, and then in the end, decommissioning that service. That's what administration certification is all about. And this certification focuses on core services of Google Cloud, which includes compute, network, storage, identity and access management, monitoring, logging, auditing, governance, risk and compliance, security services. That's what it talks about. Then we have level 300, which is professional cloud architect certification. Its focus is a level ahead of associate cloud engineer, wherein in associate cloud engineer, you learn how to provision and manage the configuration of a service. In this certification, you primarily learn how do you design and architect a service. So if you in associate cloud engineer, you learn how do we build a VPC? How do we provision VPC in Google Cloud? What are different configuration options inside a VPC? How do you configure it in the very beginning? When that VPC starts to have resources hosted inside, how do you manage the life cycle of it, which is the configurations that you keep modifying? And in the end, you delete that VPC. That's what ACE is all about. PCA, Professional Cloud Architect, is about how do you design and architect a VPC based on a scenario. So let's say you have a customer who has got uh, 10, tens of thousands of workloads and applications that customer is planning to migrate to Google Cloud. How do you build the network in Google Cloud that aligns with the customer's requirement? So you will have discussions with customers, network team. You will have a brainstorming session to understand how the current network looks like at on-premises, or if the customer is in cloud, then how they have built their cloud network. And accordingly, you will arrive at a conclusion in terms of how the network in Google Cloud would look like. So that is known as planning and designing the networking architecture in Google Cloud. That's what you discuss in architect certification. So this would include design and architecting and implementation part of those services. Then you have specialty level certifications also, which is equivalent to professional cloud architect, which are security specialty, network specialty, big data, AI, ML, DevOps, machine learning. Those are the specialty certification. They also deal with design and architecture, but they also include the administration aspect of that specific service because they primarily focus on a specific service category and all the services from that category only. So that's about how do you get started with Google Cloud? How do you get started with your journey? What certification you need to primarily start to focus with, and what should your journey be look like? That's what this uh, these certifications are all about. Then we talked about then we started with Google Cloud Fundamentals. Fundamentals basically means that what Google Cloud is all about. How is Google Cloud different from other cloud service providers? We already have leaders like Amazon Web Services, who is also a leader, the number one public cloud service provider under infrastructure and platform as a service space. And that has been there for almost 17 years now, 18 years now. So then you have Microsoft Azure, which has been there in existence for 15 years almost, and they fall at number two. So how is Google Cloud different? How are they doing business differently? Do they have different services? Are the service nomenclature different? Are they offering those services in a different manner? Is that we covered in cloud computing overview architecture and then Google Cloud, infrastructure. So I started with the very basics and then I directly moved on to global infrastructure of Google Cloud, wherein we looked at location, zone, reason, concepts. We looked at 6 layers of security at Google Cloud. So we basically went on a virtual tour along with a Google Cloud employee to one of the Google Cloud data center, and we looked at how Google is securing their data centers. We looked at physical security aspect. We looked at data security aspect. We also looked at how they are securing the data that belongs to customers from their data center floor. How many employees of Google are allowed to access that floor? How are they destroying the data when that data is not needed anymore, or when the device, the hardware, the storage hardware is reaching its end of life, how are they disposing that storage device? That's all you have seen in that video, which is 6 layers of security at Google Cloud. Then we looked at getting started with Google Cloud, and I talked about that there are two ways to get started with Google Cloud. Either you start as an individual, wherein you directly sign up to Google Cloud. If you have if you already have a relationship with Google, which is 99% of the case, Google has been providing email services, cloud storage services in the name of Google Drive for a long time. So most of the people, they eventually have an existing relationship with Google Cloud. If not, then they can start their relationship with Google Cloud by creating an account on Google Cloud, which is a Google account that gives them access to Google Drive, Google Gmail services, also Google Docs, Google Slides, Google, other Google services, which is similar to Microsoft Office. So when you have an existing relationship with Google, you can sign up for a free trial. As part of free trial, you get $300 worth of credit. You also get uh, additional $100 if you sign up with your paid account. I'm sorry, with your corporate account. So if you sign up with your corporate email address, you get $400, $300 plus $100 valid for 90 days. If you sign up with your personal email account, you get $300 valid for 90 days. Post 90 days, your account automatically gets converted to paid account, or whichever comes earlier, whether you exhaust that credit before 90 days, $300 of credit, or 90 days period is over, automatically your free credit will get disabled, deactivated, expired, and you will start to pay for the services that you have running in your account. That corresponds to a billing account that will get created, wherein you will have your payment method already configured, allowed for standing instructions, so Google can deduct the monthly bill from that payment method. That's what you get. In return, you get a project, you get a subscription. I'm saying you basically get access to a project, which is equivalent to subscription or account in AWS, subscription to Azure and account in AWS. And then you also get access to GCP console via console.cloud.google.com URL. And you basically select your default project and you start provisioning resources in Google Cloud. That's how an individual sign up to Google Cloud. When you sign up as a business, this is something that I probably covered in the last session, that when you are signing up as a business, you basically, you're expected to have a domain, a business domain already. Let's say nextturn.com. You are one of the IT team leader or senior person in the IT team whose job is to onboard or get started or start the relationship with Google Cloud. So you will first onboard your domain to Google Cloud. So you will sign up to Google Cloud Identity Service, which is admin.google.com. You will first onboard, which is you must verify and onboard your domain with Google Cloud. After your domain is verified, you will get access to Cloud Identity Service, which is equivalent to Google Workspace also. So Google Directory Services, for example, in Azure, you have Microsoft Entra ID. In AWS, you have IAM, AWS IAM and AWS IAM Identity Center and AWS Directory Service. And these services are part of Cloud Console. However, in Google Cloud, its identity service is outside of Google Cloud. It is not part of Google Cloud Console. It is positioned outside of Google Cloud. And why? Because the same service is used by Google Workspace services also. So with Google Workspace, you can have access to other Google services like Google Apps, Google AdWords. That is why they have intentionally put IAM service outside of Google Cloud so that it can be leveraged by other Google products as well. So it is the same directory service or same IAM service, which is known as Cloud Identity, that will have the capability to authenticate and authorize when you are using other Google services as well. So that's what Cloud Identity is all about. So business typically creates a GCP account after Cloud Identity, after they subscribe to Cloud Identity service, they will create a cloud account. I'm saying they will basically sign up to Google Cloud. And as part of that, they will be assigned a project that they will sign up to. And then they can create an organization. Organization is a hierarchical structure that Google Cloud provides to businesses so that businesses of any size, scale, and complexity can use Google Cloud and its services effectively, efficiently. So organization, that is known as that hierarchical structure is known as organization. So Google, on the top, you have organization, which is your root domain, which is nextturn.com. And inside organizations, you create folders. Folders are equivalent to departments and business units that you have in your company. So each department and business unit will get a folder created for themselves. And inside folders, you will create projects. Projects are containers for Google Cloud resources. Using inside projects, you basically provision services or resources. So if you need to provision a cloud storage bucket or a compute engine instance, you will need a project. You will need access to a project. Now, it is not mandatory that project will be created inside a folder. You can also create a project directly inside your organization or independently, similar to what an individual does. But this is the hierarchy that we follow in Google Cloud. This is similar to Azure hierarchy, wherein we have management group at the top or EA enterprise agreement at the top. Inside enterprise agreements, you have departments. Inside departments, you have subscriptions, and inside subscriptions, you have accounts. So this is the similar structure, which basically lets you build the Google Cloud infrastructure or Google Cloud or build and leverage and consume Google Cloud services efficiently. So if you are working for a customer who is an enterprise, who is onboarded on Google Cloud, who is using services from Google Cloud, you will typically find this hierarchy there. You will find an organization, a folder, a project, and resources as part of project. There could be multiple folders inside the organization. There could be multiple projects inside a folder. There could be multiple resources inside a project. The other benefit of it is that you will apply policies at the org level. Those policies will propagate down, and all the resources underneath will have those policies applied to them. So you can have individual resource policies, project policies, folder policies, and org policies. Org policies will get inherited by all underneath. Folder policies will get inherited by all underneath. Project policies will get inherited by all underneath. And resource policies are applicable to resources only. So that's about organization. Now, why I'm spending some time here so that I can bring you up to the speed, because now we will have this session in continuation for another couple of weeks. So I want everyone on the same page. That is why I'm just giving you a quick walkthrough of what we have covered so far. Okay, then so this is known as resource hierarchy in Google Cloud. Then what I did in the training session, I gave a demo. I basically signed up to Google Cloud. I showed you how do you sign up to Google Cloud. And in that demo, we basically signed up to Cloud Identity. We provisioned users in Cloud Identity. So I already have a Cloud Identity account. I signed into that account and I showed you how do we provision a user in Cloud Identity, and then how do you provision folders in project. And after this, these components are created. How do you sign up to your cloud console? And then how do you provision users or grant them access which are there in Cloud Identity? So that's what I showed you. So we did some hands-on lab wherein when I asked participants to create a free trial account of Google Cloud so that they can also continue to do additional services that we will cover in this training. As part of free trial account, you will get access to a project, and then you sign up to that project. After that, you can create additional projects also, and then also granting access to uh, other users, which is known as principal in Google language, to your project. So that's what we did. We basically did some labs with respect to identity and access management. This is the link for session recording, which is here. Then I also shared Google Cloud official learning and development portal, which is Cloud Boost, cloudskillsboost.google, which also contains courses. This is similar to Microsoft Learn or Skill Builder. Explore.skillbuilder.aws, which is the AWS portal. So on this Cloud Skills Boost.google, you will find a couple of courses, couple of trainings, which will include documentation, PowerPoint presentations, ebooks. In fact, some assessments are also available. And this also comes with a paid version wherein you pay $29 a month, and you can also do some hands-on lab, some simulated pre-configured hands-on lab also. So this is what we covered in the last 3-4 sessions. Now we'll continue from here. Before we continue, let me know if you have any questions from the previous topics that we have already covered. Moving on. Other than this, is there any other question from any other participants? Okay, if there are no more questions, let's get started. So now that we have completed the IAM part, I will not say that we have completed the IAM part. IAM has more to it. So when it comes to identity and access management, you have some additional topics also. However, those topics are not needed as per the content that I've received, focusing on those services, and we'll cover the level 100 part of it. So when it comes to identity and identity and access management, we also have identity synchronization. This is similar to Azure AD Connect or Microsoft Entra ID Connect or AD Connector in AWS, wherein you can synchronize your on-premise identities, your Windows Server Active Directory identities, or your identities which are part of any directory service that basically supports LDAP authentication, lightweight directory access protocol authentication, or which supports Kerberos authentication. You can synchronize those identities in Google Cloud uh, via a service which is known as Google Cloud Directory Synchronization, GCDS. So it's Google Cloud Directory Synchronization. Now, since this is a lengthy topic, which will take time, which also requires you to have an Active Directory configured, then only you will use this service. So what I will do, I have this specific topic covered in my previous session. I'm saying my previous training session. I'll share the session recording with you. You can watch the session recording wherein I'm covering this specific topic end to end, wherein I'm talking about what this service is, how does this service work, in what scenarios I can use this service, and then a lab demonstration wherein I will show how do we build this service from scratch, how do we use this service to synchronize identities, and once identities are synchronized, what additional options are available in this service to manage the synchronization going forward. So I have all of that covered in a separate training, which I wherein I focused, or uh, wherein I dive deep in Google Cloud Identity Services. So I'll share it from there if you have interest in this. So that's identity synchronization. Then you also have single sign-on and SAML-based authentication, which is another topic wherein you can have your identities, wherein you can have applications configured in Google Cloud and your identities can be provided SSO or SAML-based authentication. Also, managing identities in a multi-cloud environment. So this is another thing. So these are some additional topics that I'm not covering as we speak, because these topics are, let's say, out of scope for this training, but these are also important topics. And if you have time, you can probably practice it yourself by referring to the documentation or references that I'll share. And we can probably have a separate offline discussion if you need additional information, if you have any questions from these topics. So this is something that I'm not covering, but this is equally important. Make sure that you basically go ahead and practice these topics. So I'm just putting them out of scope as of now for for this session, but go ahead and practice it also whenever you get time. So now we will get started with the next core service of Google Cloud, which is networking in Google Cloud. So this is what we are going to focus on, that how do we do networking in Google Cloud? How I'm say how networking or how Google Cloud Network looks like, how it is different from other cloud service provider. Now, as I told you at day one, though this is Google Cloud training, but at the same time, this is not a certification oriented training. This is not a training that I'm doing for somebody. I'll deliver the training and move on, and then we don't know each other. This is more of a relationship that I'm building with Nextern. uh, I already have a good relationship with you guys. I'm saying some of you are part of my previous training assignments as well. So the focus of this training is aligned towards managing operations. That what are typical call drivers that you will get into operations when it is about networking services of Google Cloud. That's what the focus of this training is. Keeping in consideration the scope with respect to what you're going to work on. So at the same time, since you guys have knowledge of AWS and Azure also, what I'm doing while I'm delivering a service, while I'm talking about a service in Google Cloud, I'm also taking references from Azure and AWS so that you get an opportunity to compare and correlate the Google Cloud service with the service in other cloud that you already are aware of, and see how this service is different, whether this service is more efficient, more mature, or whether this service has certain limitations which are not there in the other cloud. Or if you remember, I was putting together a spreadsheet wherein I was putting a comparison across services. Comparison of services across multiple cloud service providers, which is not similar to what you see, what you get on LinkedIn, or what you get forwarded a plain image that has services name. That was a level I had wherein I was specifically talking about the pros and cons in comparison. So that sheet is currently working as we speak. When it comes into a shape wherein I feel that I can share it with you, I will share it. I'll share that sheet with you also. So let's get started with networking in Google Cloud. Now, if you remember from if you remember from global infrastructure topic, I talked about that Google has a global network. So Google has a global network spread across multiple geographies, which includes, you can say countries, or continent or countries. So it has a global network that is spread across multiple geographies. And the best part about Google network is that Google network is much more mature and advanced than other cloud service providers network. Why? Because Google has its own cloud network. Google has its own Google has done a lot of investments into building a scalable network across multiple geographies. Google has its own optical fiber cable network that span across hilly terrains as well as undersea. So Google has its own optical fiber network that spans across hilly terrains and undersea, connecting multiple locations across the world. So Google has very limited dependencies on third parties or you would say ISPs to basically provides networking services. And with this global network, Google is providing its CDN services. Google is providing its networking services for its cloud resources. And Google is also connecting multiple clouds, or Google is also providing hybrid connectivity services, which includes VPN, Google Interconnect, and other services. So that's how Google Network works. So let's understand it from the official presentation of Google. Hope my screen is visible to everyone.
Yes.
Okay, let's go ahead. So in this presentation, we will basically discuss about VPC, which is the networking service in Google Cloud, how it spans across projects, networks, and subnetworks, IP addresses, routes and firewall rules, pricing, and we will also do a lab on networking, and then we will also look at some common network designs. So that's what we are going to do here. So let's understand Google Cloud Network. Now, when you look at this image, you can see that how Google is connecting multiple regions, multiple countries in the world, and that connection, and it has multiple connections. I'm saying it has redundant connections of network. You can see between the United States of America or North America to Europe and Asia Pacific, there are multiple connections which it is creating. And this connection is undersea water cable, undersea water optical fiber cable network. It also has network which spans within the country. So you can see from Mumbai to Delhi, it has its own network, or across multiple the east coast of United States as well as west coast, the Canada, everything is connected. So when it has internal connectivity, you will see that this connectivity is over hilly terrace. It's a optical fiber cable connectivity. That's how it is connecting everything. So I'm say Google has all of its regions connected via its own global network. And that is why when you have resources configured across Google Cloud, communication from one region to another is very quick, is fast, with minimum latency, less than 10 milliseconds. Single digit latency is what Google provides. You have a concept of POPs. POPs are nothing but the various connectivities which are there, which has POPs. And then you will also see multiple regions here. In fact, this also shows all the Google Cloud regions. And it says that there is one region which has 4 zones. Rest of them has 3 zones. So all of them that you see, they have 3 zones. You also see some white circles. I'm just circle, circle with no color. That circle basically represents a future region which will be launched very soon by Google Cloud. So that's what you see here. So that's about how Google Cloud Network is spread across multiple geographies and how it has multiple connectivity options that a customer can use. So let's say you are in Tel Aviv, Ukraine, and you're trying to send traffic to Madrid, right? Now, when you're trying to send some communication to Madrid from here, depending on the current bandwidth at the available link, your traffic can take this route, which is it can travel all the way from here, which is all the way outside of South Africa, and then going through multiple pops and then finally reaching Madrid, which will definitely take time. Or it will directly take a path, which is this. It will go to one of the pop and from there it will get transferred to Madrid. So it all depends. This is known as RTT, round trip latency, that how much time it takes for your request to get acknowledgement from source to destination and vice versa. So that information is also available on Google. So it provides I'd say better round trip latency as compared to Azure and AWS. So let's understand that what are my I'm saying what is a VPC? So we already know that VPC stands for virtual private cloud. So the networking service that we use in Google Cloud is known as virtual private cloud, and it is the same name that you give to networking service in AWS. That is also virtual private cloud. So Google provides you VPC, which is your, and what is that VPC? It is your local and isolated network in Google Cloud. When I say local and isolated, it basically means that you will only have access to this network. When I say yours, it could be an individual or a business. So only that business can host services in that network. Only that business will have access to that network because the network is bound to a project. Project is bound to a billing account, and billing account is bound to a customer ID. That's how Google, carries the relationship, or that's how the relationship goes. So it's a local, it is similar to a local network that you have in on premises, and it's isolated network. Only you have access to it. Only your project has access to it. It is built inside the project. You also have a service in the name of shared VPC that I will probably talk once we are done with the normal VPC concepts. Once you have good knowledge of the VPC concepts and how do you build and configure it in Google Cloud, then we'll talk about the additional services. So it's your local network. It is similar to virtual network in Azure, wherein you create a network and you basically use that to host resources. However, it is different. Google Cloud VPC, it is a global network also. It, or you can say, it spans across multiple geos, geographies, and regions of Google Cloud. That is the difference between Google Cloud Network and other cloud network. In other cloud, when you build a network, you build that network inside a region. And you can only host resources inside that network within that region. However, in Google Cloud, when you build a network, it's a global network. You can further build subnetworks or subnets inside the network, inside a region, which means your VPC is global. It has subnetworks or segments or subnets across a region, and inside that region, you can have multiple segments. They all are part of the same VPC. So when we build it, you will understand it. So what are my VPC components? So these are my VPC components or VPC objects. We have project. So project network and subnetworks, let's understand. So project you already know is a container, and project associates objects and services with billing. So you provision a resource or a service in a project. Project has a billing account so that the billing can be done for that service. Now project contains networks up to 15. 15 is the default limit or soft limit. You can also increase it. If you already have 15 VPCs and you need more, you can increase it also. However, Google has other design patterns. Making use of those design patterns and best practices, you may not ever need or you may not reach to this limit. You will probably end up having one or two networks that will suffice the purpose. With one or two networks, you can host tens of thousands or hundreds of thousands of resources. Then comes a network. It says network has no IP address range. So Google Cloud Network has no IP address range. It is global and spans across all available regions. So Google Cloud Network is global and it spans across all available regions. It contains subnetworks. It is available as default, auto, or custom. There are three modes or three types of network in Google Cloud. A default network, which is similar to default network in AWS. Azure doesn't have a default network, but AWS has a default network. So it's default, then auto, which is another type of network, and then custom mode network. So these are three types of VPCs in Google Cloud. We'll talk about it when we reach there. So default network. When I say default VPC, you will find the default VPC in each project. Whenever you will create a project in Google Cloud, when you log into that project or when you choose that project, when you navigate to VPC service, you will find a default network. A default network which is configured with default configurations, which has a subnetwork available in all the regions, which has its firewall rules configured to allow certain type of traffic, which is a common traffic, which has routing pre-configured. So its default configuration. Let's say you are somebody who wants to quickly test the capability of Cloud SQL Service, capability of Google Kubernetes Engine, capability of Google Compute Engine. You want to check whether you will be able to host your application in Google Cloud on the top of a virtual machine. And you want to test it real quick. And you don't have good networking knowledge. In that case, you can leverage default network to build a compute engine instance, take remote or RDP or SSH into it, deploy your application, test it, and decide accordingly whether you want to continue or not. So at least you will not be challenged by Google that first go and learn networking, because before you do anything, you need to build a network in Google Cloud. That is what default network is all about, that you can use to quickly test other services or to quickly provision other resources in that network. Then we have auto mode network. Auto mode network basically means it is similar to a default network. However, the only difference between default and auto mode network is that in auto mode network, the address space that it takes for each subnetwork or for each region has /20 as side block. /20 basically means specific number of IP addresses. However, if it's an auto mode network, you can expand it up to /16. So when you reduce the number, the IP addresses increases. So /16 typically provides you 65,525 IPs, let's say. So that's the difference between default and auto mode. Default, you can't make any changes. Auto mode, you can make changes. You can expand the IP address space from /20 to /16. Then come custom mode. Now this is the actual network that you will create in production. So you will create a custom mode network wherein there is no default subnet. You will decide whether you need resources provisioned in a specific region, in a specific region or location. If yes, then you will create a subnetwork in that region with your choice of IP addressing. So it's a no subnet and it provides you full control of IP range. In default and auto mode, Google will pick up the IP range itself. However, in custom mode, you can pick and choose your own IP address space that you want to use in Google Cloud. It provides you regional IP allocation. You can provide IP, address spaces to regions also, and it can expandable to IP ranges you specify. So since it's a custom network, you will need to design according to your near-term and long-term IP addresses requirements. So if you are a customer who probably needs to host 500 resources in Google Cloud today, but in next 5 years, it will increase to 5,000. You can plan it accordingly. You have full control on this network. So this is how isolation works. As I said, network also creates isolation. Now imagine that we have multiple networks in Google Cloud. So look at this image and try and understand how isolation works. So we have multiple networks here. We have network one, network two. Give me a moment, guys. Somebody is at the door. I just come back. Meanwhile, you just try and understand this image and all the options which are there. Right, I'm back. Okay, so uh, so let's understand this image. This will help you understand a concept of isolation, that how Google network provides isolation. So we have 5 networks and they are across regions also. So you can see there are 5 networks and they have resources configured across region. For example, the network one has a virtual machine. This is the icon for compute engine instance or a virtual machine. So network one has 2 resources, virtual machine A and virtual machine B. Now, since they are part of the same network, however, if you see their allocation, I'm saying if you see the location, virtual machine A is configured in US East 1 and virtual machine B is configured in Europe West 1. So they are across region. One is in United States, the other is in Europe, which is like 1,000 miles away from each other. So one is in United States, the other was in Europe, which is 1,000 miles away from each other. However, since they are part of the same network, they can communicate over internal IPs. Internal IPs basically means on a private IP. So here you can see A and B can communicate over internal IPs, even they are in different regions. Let's talk about other networks. Now you can see network 3 and 4, they also have resources. And eventually, both the machines are in the same region, which is US East 1. So here you can see C is in US East 1, part of network 3. D is in US East 1, part of network 4. However, they are in the same region, but they are across network. And since they are across network, they cannot communicate directly over internal IPs, over private IPs. If they need to connect with one another, the connection will be done over the internet. So you can see if C and D are communicating, the traffic is moving out of Google Cloud all the way to internet, and then from internet it gets routed back to network 4. So C and D must communicate over external IPs, even though they are in the same region. Now, over the internet, you can only communicate when you have a public IP. So this is how networking works. One thing is missing from this image, which is connectivity. What if I want my resources C and D to communicate over private IP? I don't want to use public IPs at all. I don't want my communication to propagate over the public internet, which is full of issues, full of security vulnerabilities. Hackers are there. I want an internal communication. For that, Google provides you a capability to connect both the networks, which is known as peering. So you can peer networks in Google Cloud. Once they are peered or once they are connected, they will act as one network, and resources inside the peered networks can communicate over private IPs. So This is something which is missing here, or you can say that the image is only talking about isolation. That's the reason they're not talking about peering here. That's how isolation works in Google Cloud or in other clouds also. Okay. So guys, if you have any questions, you can raise your hands or you can ask when I take a pause or when I encourage you to ask questions. Yes, Kiran.
So actually, I just joined today only. So I just
Yeah.
want to know like whether we covered IP addressing part earlier or it's not yet covered.
No, so IP addressing from the basics perspective, obviously I will not be covering because we are focusing on Google Cloud. I will be
Mhm.
covering the Google Cloud network. But if you need a basic understanding of IP addressing, which is how an IP address work, how subnetting happens, how do we segment a larger address space into smaller IP address spaces, what are different types of IP addresses, what are different types of classes, like what are different type of IP addresses, public, private, what is allocation, static, dynamic, what are different classes of IP addresses, class A, B, C, D, and E,
Yeah,
what is the IP address range in each class, public and private. If you need to know all of it, that is not covered here in this training, but I have a previous training session recording available that you
yeah,
can that I can share, or I can upload it to my YouTube channel and you can watch it from there. That will
sure,
help
sure.
you understand the basics of IP addressing, which is very important to understand the Google Cloud Network. Because so, as I said, Google VPC is global. When I say the VPC is global, it basically means that I can create one VPC, and with that one VPC, I would say I don't need to create multiple VPCs similar to Azure and AWS. I can only create one VPC, and inside that VPC, I can host resources in any part of the world. When I say any part of the world, I mean to say in any Google region where Google has its region, which is live, which is working as we speak. So this is how Google VPC works. So this image is basically for Google VPC. It basically shows you that how VPC is working or how VPC is configured. So you can see Google Cloud VPC network. This is the icon for Google Cloud VPC network. You see two subnets here, two subnetworks here. One subnet is in US West 1, the other is in US East 1. Now this East 1, West 1 basically means how many regions in US. So in US, they have many regions. That's why they denoted like US East 1, US East 2, West 1, West 2. And here you see virtual machines deployed in those subnetworks. They are known as compute engine virtual machines. These virtual machines can communicate. That's why the communication channel is shown as green. It's a green arrow, which means they can talk to one another without any trouble over private IP address range. And when they need communication with on-premises resources, let's say this is your on-premises site, your office, where you have some resources that needs to communicate with these virtual machines. So how that communication is possible? How that communication is possible? Through a
बीस
VPN,
बाईस दिन
a virtual
हाँ
private
बोलिए
cloud, right? So through a virtual private cloud, you can you can see the communication. Now you can see this on-premises resource, which could be a laptop, desktop server, is basically using a VPN gateway or the VPN virtual private cloud network or a VPN tunnel to communicate with this instance or to communicate with the other instance. So that's a typical representation of a Google VPC, and you can span this VPC across multiple regions. Next, then comes subnetworks. Now, what is subnetworks? Subnetworks is the segmentation or breaking a network into multiple smaller networks so that you can host resources based on their role, based on their architecture, based on their requirements, connectivity requirements. For example, if I have, let's say, if I have, if I have a three-tier application that I want to host in Google Cloud. Okay, by mistake, I opened session transcript for another training that I completed recently. Session transcript, April 20th. This is not the one. This is the session transcript for yourself. Okay. So let's say I want to host an application a three-tier application in Google Cloud. Now, when I say three-tier application, I'm talking about a front end, which is my web tier. Then there will be a middle tier. I'm saying middle tier, which is my app where I put my applications. Here I put my web servers. Here I put my application servers. And in the backend tier, I will put my databases. And then I will also have some management services. Management services that I will basically use to to provide uh, connectivity, to provide additional services. For example, I will have a directory service which will be used for authentication and authorization. I may probably have a monitoring service. I may probably have an antivirus, next gen antivirus solution. I may probably have some application performance monitoring system. So I will have some additional services also. Now, can I put all of these servers into one place? I would say, can I put them all into the same network, into the same segment? No, I cannot put them all at the same place. And that is what you will see from my basics, basics recording, networking basics or IP addresses basics recording. Why I cannot put them all at the same place? Because their connectivity requirements are different. Web servers typically accept traffic or communicate over TCP IP port 80, 443, or any other configurable port, custom port like 8080, etc. That's what web servers communicate. Similarly, application servers, they communicate on specific TCP IP port. Their port requirement is different. Databases port requirement is different. Let's say there is an application server that communicates at 5723, 5724. So these are the ports on which application servers communicates. These are the typical ports. Then database, it communicates on TCP IP 1433, 1434. These are the ports or databases that databases communicates. So their communication requirements are different. Similarly, the level of security that they need is also different. You cannot have the same level of security configured at web server and at the databases also. So typically web servers are internet facing. They are public facing. They basically accept end user traffic, and middle tier and backend tier and management services. They are internal to the organizations. They are configured in a private network. So their networking requirements are different. And since their networking requirements, connectivity requirements, security requirements are different, I'm saying web server is nothing but that contains the web services and the root of your application. But database is very critical. It actually contains the data. You can lose your web server and rebuild it in a couple of minutes. What if you lose your database? What if the data is stolen? You cannot rebuild it. Once it is stolen, once you lose your credibility in the market, you cannot rebuild it again. It is very difficult. So it is important to protect it. And that is why when we cover networking, we are not covering networking, we're covering security. When we are covering identity and access management, we're covering security. Any service that you will learn in cloud, you will automatically learn security. Automatically, you will learn it because cloud is all about security. Cloud is all about cost optimization. Cloud is all about innovation, modernization, being cloud native as much as possible. So the connectivity requirements are different, and that is why we create subnetworks. We create smaller segments of network and we create them across zone. Now, this is where you will see it. So when we create subnetworks, you will see there are, so we are creating this subnetwork and we are choosing the zone here. So this is basically different from Azure and AWS. If you if you come from AWS background, you will notice that when you create a subnet in AWS, they use the terminology of private and public subnet. And when you create a subnet, let's say you say that I want to create, you basically choose a zone in AWS. So you choose zones. Let's say if you choose two zone A and zone B, it will automatically create one public and one private subnet in each zone. So subnets are a component of a zone in AWS. In Azure, zone has nothing to do with network. Networking is separate. Availability zone concept is separate. However, in Google Cloud, zone are part of your subnet because it's a global network. So you create a subnet, and when you provision resources in the subnet, at the time of provisioning, you can select the zone, that in which zone you want to provision the resources. That's how network in Google works. So it says VMs can be on the same subnet, but in different zone. So these two VMs are part of the same subnet A, subnet -1, but they are part of two different zones. Now, if you want to understand what is this zone, what significance it plays here, how it helps Google to provide you, high availability of your resources. You will probably need to watch the previous recording for day second or day third, which is 17th or 18th of April, wherein I'm talking about these concepts in detail, that how these concepts work. So look for those recordings, you will understand the zone concept. Then it says a single firewall rule can apply to both VMs. Now, this is another thing in Google. Since it uses a global network, there is a common firewall. A common firewall that you will configure to control, restrict, allow traffic to your network across the region, across all the regions. That's what it does. Then you can expand subnets with or without recreating instances. Now, another capability that Google provides is that let's say you are running short of IP addresses in your subnets, you can expand them. You can add more IP addresses to your subnets. You don't need to recreate the subnet. However, make sure, and it is not with Google, it's a networking thumb rule. IP addresses, IP address space must not overlap. It's a thumb rule of networking that your IP address space must not overlap. If it overlaps, overlapping basically means that you end up using the same IP address space for multiple networks, or some machines have the same IP address. That is known as conflicting IP addresses, coinciding IP addresses, or overlapping IP addresses. If IP address space overlaps, you will not be able to enable the communication. The DNS resolution will fail. Machines won't be able to communicate. Services will not communicate with one another. So you cannot create overlapping subnets. IP address range must be unique with a valid CIDR block, which is /20, 21, 22. New subnet IP range have to fall within the valid range. The network can expand but not shrink, which means you can start with, let's say today when you start your address space, you will start with /24. You take a class C private IP address range, which is 192.168.1.0/24. Now this range gives me 256 IP addresses, 256 IP addresses. But, and let's say those 256 IP addresses are exhausted. You're running short of IP addresses. You can always increase it. You can always expand it, but you cannot shrink it. You cannot do this 192.168.1.0/23. Sorry, 25. When you increase the number, the IP addresses decreases. When you decrease the number, IP addresses increases. So if I say /25, then the IP addresses that it will have is 128 IP addresses. This is not possible. And it is not that this is not possible in Google. This is not possible in any cloud. They don't allow shrinking, and not for IP addresses only. They also don't allow shrinking for other services like volumes, disk. You cannot shrink them. You can always expand them. And this is done for a reason. And that reason is that it will not affect your data. You will not lose any service. So you cannot shrink, but you can always expand. Auto mode can be expanded from 20 to 16. As I said in the previous page, that if you start with an auto mode network, it will have /20 and you can expand it to /16, which means more IP addresses. However, at the same time, it is a best practice to avoid large subnets. You should not create large subnetworks. It is like purchasing a 16 BHK home for a family of 4 members, husband, wife, 2 kids. What is the point of doing it? You may say that I have a lot of money. I'm saying I can do it, but understand the logical aspect of it. You are 4 members in the family. You will settle down at the max in 4 rooms, but you still have 12 additional rooms. They are empty. Nobody is living there, but you still end up managing them. You will need to make sure that they are cleaned on regular basis. You will need to put electricity. I'm saying you will need to make arrangements to, to manage them. And there is no point of doing it. You're just wasting your money. And at the same time, there is a security concern because since you're not visiting to those rooms all the time, you probably have insects, you probably have security issues. So there is no point of purchasing a 16 BHK home for a family of 4. Same is the concept here, that you cannot plan for 100 years in advance. Now, when I gave this example in my previous training, one of the participants said, "Sir, I have taken future in consideration. When my kids grow, they will get married. They will have kids who will stay in the remaining rooms. Then their kids will grow, they will get married, they will have kids. I will have grandkids, then I will become great grandfather. And that is way I can manage all those 16 rooms." So it is like investing today for something that will happen 20, 30, 50 years in future. From the investment perspective, it looks good because the property prices increases. But from the networking perspective, it's a bad idea. It is like unnecessarily expanding your attack surface area. You will have more probabilities of network intrusion when you have a larger network, but you actually are not managing it. And also, what is the guarantee that your I'm saying that the kids of your kids, your granddaughter and grandson, they will live in that same house. They will probably want to buy a separate house for themselves. They will probably move abroad. Same is the case with this example wherein you build a large network today thinking that I will reuse this network in future when I have more services that I need to host. What if the service owner or the application owner needs a separate network of its own? Then you will need to build a separate network. Then what is the point of this network, which has large subnets? So the fundamental rule of networking, another fundamental rule. The another fundamental rule, it says start small and expand when needed. This is another fundamental rule of networking. You should always start small and expand when needed because network is scalable. You can expand your network anytime you need. So start small. Consider near-term requirements, probably 6 months down the line, future requirements, but do not plan your network considering what will happen in 2034, 10 years from now. Don't just do that. That's the another fundamental or best practices of networking. Okay, so this is this is why we need to avoid large subnets because it is against the best practice. It will increase your attack surface area. It will have more probability of network intrusion and the security will go for a toss. So that is why it is not advisable. And it may also create shortage of IP addresses in future, or it may create overlapping scenarios also. So you can see here we have a project. Inside a project, we have a network. And inside the network, I'm saying that network is spread across multiple regions. In region A, we have 2 subnetworks. In region B, we have a single subnetwork. In region C, we have a single subnetwork. Probably this customer started with 1 subnetwork in each region. So customer started with this address space, which provided him, let's say, 256 IP addresses. And when those 256 IP addresses were exhausted, then the customer built another subnetwork with a larger address space, because this is where the customer is more heavy. But for the remaining regions, the customer is quite doing good here. There is no challenge. They have sufficient IP addresses. So that's the concept of starting small and then expand when needed in future. Or you can expand when it is needed. Okay, next, let's look at the IP addresses. Now, my virtual machine that I will build in my network, it has two IP addresses, internal IP address and external IP address. Internal means private IP, external means public IP. The internal IP address that my machine will get will be allocated by DHCP service, which is managed by the VPC itself. DHCP and DNS is provided by VPC service in Google Cloud or in all the clouds, which is name resolution and automatic assignment of IP addresses to resources. So that internal IP is allocated from subnet range to VMs by DHCP. DHCP lease is renewed every 24 hours, which means every 24 hours, the IP address may change. Or if you shut down your VM and turn it back on, it may have a different IP address. It may acquire a different IP address. Now, how it is registered in DNS? VM name plus IP is registered with network port DNS. So when you look at the DNS name of your resource, it will have VM name plus IP address. Then comes external IP address, the public IPs. Now, public IPs comes at a cost, and they also comes with a lot of responsibilities and security issues. A resource having public IP is accessible over the internet, has access to internet, both things. So you should be very careful before assigning public IPs to a resource. You should only assign public IP to a resource that needs to be accessible from internet, like web services, any public facing website, application, or portal. That should be assigned external IP. This external IP comes from pool, Google public IP pool. So Google has a pool allocated or reserved for each region, not for a customer, for a region. From that regional pool, you will be granted public IPs, and they are ephemeral. Ephemeral basically means that they are not permanent. You can get public IPs, you can release them also. However, you can also get static public IPs. Static public IPs basically means that ephemeral IPs are dynamic in nature. They may change when you reboot your instance or after the lease is expired. But if you are provisioning a production deployment, production server, and that server is hosting a public facing website of your business, you don't want your website to go down, to face DNS issues. That is where you will take a reserve IP, which is similar to Elastic IP in AWS and public IP in Azure. You can also bring your own IPs. This is another benefit that Google provides, which is not available with other cloud. Google says that if you have purchased public IPs in on-premises for your business in the past, now you are moving to my cloud, you can bring your public IPs. I will allow you to use your public IPs in my cloud. You just need to register those IPs with me so that in future, if somebody asks who this IP belongs to, because the name resolution will point towards my network. So I will just need to have your public IP registered, add it to my IP pool, and you can use them. Rakesh, do you have any question?
Yes, sir. Actually, in case of internal IP, if I want to give a static IP to any VM, I
Mm-hmm.
cannot give. Like because in this the scenario is like sometime in Azure, like you need to connect with some gateways like
Mm-hmm.
VPN. So
Mm-hmm.
that time we need to go with the private IP. So in
Mm-hmm.
this case, you are telling that every 24 hours our IP is getting changed. So how we can use this and some don't want to use any external IP. They
Okay,
just want to use any gateway. Like how they will
right.
use.
So what you can do in this case, this is the default arrangement, default nature, default behavior. You can always customize it. You can change the allocation method from dynamic to static. That's first thing. Second, resources communicate over the network using two methods, FQDN and IP address. FQDN basically means resource name, which is the machine name, and IP address is the IP address. As per the best practices, we should always use FQDN for communication, not IP addresses. Why? IP addresses may change in future, but FQDN will always remain the same. For example, your laptop, the laptop that you're using, if you open command prompt and say host name, you will find the name of your laptop. Now your laptop is moving. I'm saying you are currently working from home. It has a different IP address. Tomorrow you will come back to Hyderabad to your office. It will have a different IP address. You will travel to, you will travel for business. You will connect your laptop at the airport Wi-Fi. It will have a different IP address. So the IP address will keep on changing. What if you tell somebody IP address of your laptop for communication, then they will not be able to communicate. But on the other hand, if you use FQDN, which is the name of your service, then it will always remain the same wheresoever you go, whichever network you connect to. That is why in business, in a production environment, applications or components of applications, they communicate using FQDN, not IP addresses. But to answer your question, yes, we can change the IP address allocation method from dynamic to static so that the machine will never lose its IP address. It will always have that IP address allocated to itself. That is very much possible in Google Cloud. Hope that answers your question.
Yes.
Okay, moving in. So the other thing that you need to remember is VM doesn't know its external IP. It is mapped to the internal IP. So a virtual machine in Google Cloud and in AWS Cloud, it doesn't know its public IP. It will always communicate over private IP. Whenever the request goes from that VM to other VM, public IP will be used. Even if that VM tries to connect to internet, public IP will be used and the network address translation will happen at the perimeter layer, at the network perimeter. There will be a gateway. That gateway is responsible for replacing the private IP of the VM with its public IP so that the request can be forwarded to the internet, to the public network. That's how it happens. All right, moving on. Then comes, this is how it is mapped. So it says that VM doesn't know its external IP. It only knows its internal IP. So that's how they map the IPs. So you can see, I'm saying this is an instance which is using Linux. That's the reason you see this command sudo or you see connection method as SSH here. So here you can see this is the private IP address of the instance. And this private IP address is mapped to the VM. VM doesn't know its public IP. Okay, then DNS resolution. How DNS resolution happens? How do I know the other person name, or how am I able to connect to the other person? That happens by VPC. So VPC provides DNS resolution, which means each instance has a host name that can be resolved to an internal IP address. The host name is the same as the instance name. So in Google Cloud, the host name is same as instance name. Wherever in AWS, your name is different, AWS uses the concept of resource ID, instance ID. So in AWS, it is different. The name of the service, you can put it as per your requirements. However, the service ID is different. You cannot change the service ID. In Azure, the name that you have on the portal for a service, you will find the same name inside the OS also. But in AWS, sorry, in GCP, it is the same thing that you have in Azure. AWS is different here. So what happens in Azure? The same experience you find in GCP also, wherein whatever name you will put to a service, it will be the same DNS name of that service. Example, my servers.us central 1 AC guestbook hyphen 156.internal. So that's how the DNS is. Name resolution is handled by internal DNS server. Google has its own DNS server that handles the name resolution. And that name resolution service is provided as part of Compute Engine. It is configured for use on instance via DHCP, provides answer for internal and external addresses. So Google provides DNS services. And if you don't have if you want to use your own DNS services, then you can use another service in Google Cloud, which is the DNS resolution service. So We'll talk about that later on. Then comes DNS resolution for external addresses. For external addresses, the DNS resolution is also provided by Google. So Google uses its cloud DNS service to provide DNS resolution. Host DNS zone using cloud DNS. Now you can use cloud DNS service of Google to host your DNS zone, which basically means that typically we get DNS services provided by ISPs. So in a corporate environment, you have your internal DNS server. DNS is a role which is part of Active Directory. So when you deploy a directory service, it has integrated DNS, which means all the resources in your network, they will get DNS resolution from directory service. If directory service doesn't have DNS information of a specific resource, the resolution will be done by the ISP DNS server. If ISP DNS server doesn't have that resource information, it will go to the global DNS, top level DNS domain. That's how DNS works in over the internet. So it says Google uses its own DNS service, which translates domain name to IP address. It provides low latency, high availability. High availability means whenever you type a resource FQDN or resource name UNC, which is Universal Naming Convention, it will always resolve it to an IP address so that you can connect to it over the internet. And it's highly available, 100% uptime SLA. Create and update millions of DNS records. You can configure it using UI, command line, or API. So that's for cloud DNS service. Next is assign a range of IP addresses as aliases to a VM network interface using IP address alias. Now you can also have virtual machines with multiple IP addresses, or a virtual machine with multiple NIC and multiple IP addresses on the same NIC. That is also possible in Google. These days, we typically don't use these concepts because nowadays IP addresses are available. There is no cost for it. And we have services that can handle. I'm saying in the past, we had issues with with servers. We have resource crunch or virtualization cloud technology was not there. So for each application, we ended up purchasing a server. And to optimize the cost of that hardware, we would end up hosting multiple websites on the server so that the resource utilization can be achieved. But in cloud, you can purchase machines based on your application requirement. And those are scalable, which means today you can go with 2 CPU cores, 4 GB RAM. If you feel tomorrow that this is too much that you have provisioned, you can resize the machine to 1 CPU core and 2 GB RAM, or 1 CPU core, half a GB RAM also. Or if you feel that you have provisioned very small machine, it is not able to handle the traffic, there are performance issues, you can upsize the machine to 4 CPU core and 8 GB RAM also, which means it is on demand availability of hardware resources. That is why you don't typically go with hosting multiple IPs on the same VM. You would rather create multiple VMs so that each application has its own infrastructure that you can manage separately. See, hosting multiple websites on the same server will also have availability issues. What if you need to, what if you need to repair or let's say perform maintenance for one website that requires a reboot of the server? The other websites will also get rebooted, or they will also need downtime, because when you reboot the server, all of them will go down at the same time. So that is why hosting multiple resources on a server or multiple websites on a machine is not recommended in the world of cloud or in the age of cloud, because now cloud provides you on-demand resources. However, this is possible. Then comes routes and firewall. Now, what is this route? This is another concept, which is, so you already understand what a route table is. A route table is a service that contains routes. It's like Google Map. Google Map knows everything. It's like a route table. You want to travel from source to destination, and you're not aware of which route to take, which road to take. You are completely lost. You can, if you have a mobile phone with internet connectivity, you have Google Maps there. Just open Google Maps, type that I want to go to this destination. It will provide you multiple paths and you can pick and choose the one based on your requirement. So it will provide you the path which is probably lengthy but has low traffic, a path which is short but has traffic, a path which goes through a path which has tolls on it. So you can pick and choose. Same is the case with route table. It contains routes. It knows the destination. So whenever a resource inside a network needs to communicate, it will basically, the traffic is sent to the route table. All outbound traffic goes to the route table. Route table will know where it needs to be sent or forwarded further. So route table will forward that traffic. In the world of internet or in the world of network, the is traffic is known as packet, IP packet. So whatever you communicate over the network, the communication is happening in the form of 0 1. That is from the communication perspective, that how it travels inside a wire, and that 0 1 is nothing but IP packets, which contains your source IP, source port, protocol, destination IP and destination port, and the message which is there in your communication. So that is known as packet. So it says every network has routes that let instances in a network send traffic directly to each other. A default route that directs packet to the destinations that are outside the network. So you have default routes, and firewall rules must allow the packet. So packet is your traffic. So you have routes and firewall, which is also part of your networking service in Google Cloud. Next, route maps traffic to destination network. So when it comes to uh, route table, it knows everything. It knows all the services inside your network and over the internet also. So whenever you request for a resource, let's say in your from your instance, you type the address of an internal resource over the network, the route table will connect you. If you type an external resource like yahoo.com, google.com, gmail.com, it will still connect you because it has the information. So you can see there is a route table which contains all the information. Now this is the route table. It contains information of all the resources. For example, this IP address, this IP address, this IP address, and this IP address over the internet. Route table contains all the thing. So let's say this instance 192.168.5.0/24. This is the subnetwork which contains this instance. This instance is trying to send a traffic to this instance, which is 10.146. What will happen? The request will go to the route table. Route table knows where 10.146 is. It will quickly send the traffic to this instance. That's what route table does. It's like Google Map or security guard in your office or reception, the receptionist. When you are in doubt, you basically go to security guard or receptionist and say, hey, I want to meet this person. I want to, go to that department, or I'm actually looking for this. So the guard and receptionist, they tell you that, sir, if you are looking for this, this is the path that you need to take. Go on the third floor. There you will find the department. Go inside. You will find that person sitting on that cubicle. That's what routes are. So it's nothing but the traffic, nothing but the information about the source and destination. So it says apply to traffic egressing a VM. Egress basically means outbound traffic. This is where you need to understand the terminologies of Google Cloud. Egress stands for outbound traffic. It says any traffic which is leaving the VM, route table applies to it. Forward traffic to more specific routes are created when a subnet is created. So route table is created when you create a subnet. Enable VMs on the same network to communicate. Route table allows a VM or virtual machines on the same network to communicate. And destination is in the CIDR notation. Traffic is delivered only if it is also matches a firewall rule. So it is not that route table contains, for example, you go to the security guard and say, I want to meet Harsha. Security guard says you go on the third floor. To your right, you will see management cubicle. Harsha sits to your left, right, right before you enter the cubicle. Now you go on the third floor. There is another security guard and you are not wearing your ID card. He will not allow you to go inside, which means you are not a destined resource. Or you have a security guard, but nobody before manager level is allowed to enter that department. But you are an associate. You will still not be allowed. Why? Because you're not satisfying the firewall rules. You're not satisfying the traffic rules. So that is the same thing. Firewall has information in terms of what it needs to allow, what it needs to block. So if you are trying to send a request to a database server, and if the firewall rule doesn't allow any traffic from the internet to the database services, your traffic will get discarded at firewall, your IP packet will get dropped, or your communication will be denied at firewall. That's what firewall rule does. So here you see the example of instance routing tables. Said that this is the instance, it contains these route tables and which has information about other routes. Okay, then comes firewall. Firewall rules protect your VM instances. So today we will be completing the theoretical aspects, and tomorrow we will spend time doing the hands-on lab around networking. Now I cannot do 2 slides and then do the hands-on and then come back and do 2 slides, because that's not how it works. You first need to understand the networking concepts, the building blocks of Google network. Then we will get into the hands-on part. And while we are doing the hands-on, we can probably come back to the presentation to have any concept or to discuss any concept which we are leaving here. So then comes firewall rule. Now, firewall rule protects your VM instance from unapproved connections. As I said, you are a resource over the internet. You're trying to connect to the database server of an application. The firewall will not allow you to send traffic because it is configured to only allow traffic from application server to database server. Even the web server is not allowed to communicate with database because web server is internet facing. It is exposed to the internet. So that's what firewall does. It says VPC network functions as a distributed firewall. Firewall rules are applied to the network as a whole. You have one firewall in Google, which is sitting at the top of the VPC. Every traffic that comes in or goes out has to pass through that firewall. Connections are allowed or denied at the instance level. Firewall rules are stateful, which means if I don't allow inbound traffic on port 80, then the outbound traffic is also not allowed for that inbound traffic. Imply deny all ingress and allow all egress. By default, firewall blocks all incoming traffic. Ingress is incoming, egress is outgoing. By default, it blocks all incoming and allows all outgoing. This is how the default behavior of the firewall is. This is how a firewall rule composed of. So you have direction, source or destination, protocol. When we do the firewall rule, we'll come back to this page and then you will see it how these are configured. Now this is the firewall rule use cases, egress, that how it works. So basis on the traffic, whether it is destined to internet, whether it is internal traffic, firewall will come into the picture. Then comes pricing. What is the cost of VPC? Absolutely nothing. It is zero. VPC comes at zero price. There is no cost for VPC. However, when you do the communication, when resources inside VPC communicates across region, across zone, then you will charge for some egress traffic, which is very substantial. So this is the charge per GB. Now let's see this. If you just calculate for 400 GB of data transfer, you are paying $1. So when two VMs have 100 GB equivalent of data transfer, equivalent of communication, then you will pay $1, which is equivalent to, let's say, less than 100 rupees. So there is a charge, but it is very substantial. It's not that significant. Now you can see there is no charge for ingress traffic. Now this is another thumb rule of cloud that you need to remember. What comes in is free, and what goes out is paid. This is another rule of cloud. You can bring terabytes of data into cloud, and this is common for all the cloud. You can bring terabytes of data. They will not even charge you single penny for bringing data into the cloud. They'll only charge you storage cost, that you're storing 1 terabyte of data. Please pay us storage cost, but there is no cost for bringing the data in. But when you want to take data out, when you want to download one file, you will be charged for it, which is your egress charge, the one that I've shown you, which is $1 400 GB of data transfer. If you are transferring bulk data from Google Cloud, they will throttle, they will put a limitation, fearing that you are leaving Google Cloud or fearing that there is some malicious activity which is going on, which is trying to steal data from your network or from your resources. So no cloud would want you to leave, but they are more than happy, warm welcome with open arms when you come back, when you come inside the cloud. So this is what you need to remember always. So you need to be very careful when you're designing the cloud infrastructure for your customer. Always go with multi-cloud strategy so that there is no vendor lock-in and you can get best prices from each cloud. So if you find storage service is cheaper in Azure, you can go for storage in Azure. If databases are cheaper in Google Cloud, build databases in Google Cloud and have Azure and Google communicating with the help of network connectivity, with the help of VPN. That is the right approach. So this is the cost that you see. By default, there is no cost for incoming. But if there is a egress to the same zone, internal IP, when resources within the same zone are talking, there is no charge. When egress to Google products, like if from your machine, if from your compute engine instance, you browse YouTube, Maps, Google Drive, or any Google product, there is no charge. Google doesn't charge for its own products. Egress to a different Google Cloud service within the same region, exceptions, no charge. Egress between zones in the same region, there is a charge. Now, one machine is in US East 1, the other machine is in US West 1, which means they are two different zones in the same region. Then there will be a charge, which is the same charge. Egress to same zone, between regions, same charge. Egress between regions, not including traffic between US regions, varies by regions. So when you're sending traffic from US to America, sorry, from US to India, or from India to Europe, there will be a different charge. Then comes the pricing for IP addresses. Google can give you as many IP addresses as you need, but you will need to pay. The cost is if you want to purchase a static IP address, it is assigned but unused. I'm saying they have also followed AWS concept. What used to happen in the past, you will only get charged for a public IP when you use that public IP. Today, they charge you for public IP even if you are not using it. So it is like if you get a public IP assigned to your account, they will charge you for that public IP even though you're not using it. It says assigned but unused. This is the charge. So they are penalizing you from unnecessarily storing public IPs and not using them. But if you are using the public IP, then this is the charge. Static and ephemeral IP addresses in use on standard VM, this is the charge. Static and ephemeral IP addresses, ephemeral means dynamic. IP addresses in use for printable VM, this is the charge. Static and ephemeral IP addresses attached to forwarding rules used by CloudNet or Cloud VPN tunnel, this is the no charge. So when you provision a CloudNet service or a VPN service, there is no charge for it. Okay. Now the question is, you are new to Google Cloud and you will always have a limited budget. No company has a lot of cash to spend or waste in purchasing infrastructure resources or IT resources. They will always have a budget. So the question is, if I have a budget, but I am not sure about the charges, it is a new service. Will I first configure the service, use it for a month, get the invoice, and then be aware of what the charge is, which could also be a surprise? Instead, all the cloud service provider provides you a calculator option. So Azure has a pricing calculator, GCP has a pricing calculator, AWS has a pricing calculator. You can navigate to pricing calculator service and you can select the service and identify the approximate charges that you will end up paying. That will give you a fair idea whether you want to use that service in that cloud or not. Or it will also help you to compare. So let's say you need to host a website in cloud on a server, and you typically require 4 virtual CPU cores, 16 GB of RAM, and 100 GB of storage. That's what your requirement is, and you want that VM with Linux or Windows operating system. and you want to know how much it will cost me, you can go to pricing calculator, select the service, select the configuration. It will give you the approximate pricing that this is your estimate. Take the estimate from all the three clouds and then make your decision whether you want to do it in Google, AWS, Azure, Oracle, Alibaba, IBM, or you want to stay on premises because that is where you are quite happy. So that pricing calculator will basically help you with that. That's it. So this is where I will end the session today. Lab is something that we will do tomorrow, first thing when we connect. So the entire session tomorrow, we will be spending doing labs for VPC, and we will look at various aspects of VPC. We'll provision, we'll see the default VPC, we'll create an auto VPC, we'll create a custom mode VPC, we'll configure firewall rules, we'll configure routing, we'll look at various aspects, we'll see how do we expand an automate VPC, how do we add more subnetworks, how do we delete it. So the entire 2 hours we're going to spend tomorrow on doing the hands-on with VPC networking. So what is needed for tomorrow? A, you should have fundamental knowledge of IP addressing that you can find from my recorded session videos on my channel. Second, you should have access to a trial account of Google Cloud. If you don't have access, where will you create your VPC? So I had some participants showing concern that they could not create a free trial account in Google Cloud due to certain payment issues or credit card not being accepted or whatnot. So is it the same issue, guys, today, wherein you still have not been able to figure out or resolve that issue, or you were able to figure out, you now have a Google Cloud trial account available with you that you can use for hands-on lab, for rest of the services that we will cover in this training. What is the status, guys? Rakesh, is it working for you now?
So previously it is working for me. Right now it is showing for verify that account. We need might need to upload the PAN card and voter ID card. I'll check and I think I will do by tomorrow.
Okay, please make sure that it is working for you. So this is for all the participant guys. This is what we need. Prerequisite, or I would say hands-on lab prerequisites. Hands-on lab prerequisite, which is a working Google Cloud project is what you need, or I can say free trial. This is what you need. If you want to create a free trial and don't know where to create it, or for participants who have joined the session today only, I'll share the link also. Google Cloud free trial. Get started for free. So this is the URL. I'm saying, okay, let me open that in incognito window. Otherwise, you will get a long URL. So you can type sign up to Google Cloud and you can say sign up for free. However, you can type just this much of it. Hit enter. Yep, it will take you to this URL. So this is the URL, guys, that you need to type if you want to take a free trial, if you want to subscribe to free trial that you all need, which is a prerequisite for hands-on lab tomorrow. Please make sure that you have access to the free trial so that you are able to do the lab. That is all for today, guys.